Hello students, welcome to my class. In my last lecture, I was discussing about the theories related to this chapter. Today, I am going to discuss few questions on this topic. So, let us start the topic, that is the question number 1. Read the question carefully, what is given here. Now, a first order reaction has a rate constant. What is given here? Rate constant, that is the value of rate constant is 1.15 into 10 to the power minus 3 per second. Yes sir. How long will 5 gram of this reactant take to reduce to 3 gram? Again I am repeating, how long will 5 gram of this reactant? That means to say, my friend, here is given A naught is equal to 5 gram and A is equal to 3 gram. So, what we need to find, that is how long, that is the time we need to find. Now, is there any formula to link this? Yes, definitely. As we know, for first order reaction, listen carefully, for first order reaction, yes sir, that is K is equal to 2.303 upon T log A naught upon A. Yes sir, definitely. K is equal to 2.303 upon T log A naught upon A. Now what will happen? Put the value. K is equal to 2.303 upon T. What is T here, my friend? That is, we need to find the value. Log A naught. What is A naught here? 5, and A is equal to, my friend, 3. Yes sir. Now what is the value of K here? Put the value 1.15 into 10 to the power minus 3 is equal to 2.303 upon T log 5 minus log 3. Now it's up to you. After solving, you can get the value of T. This is the case, my friend. Simple question, completely formula based question. Put the formula, write the formula, put the data in the given formula, you will get the answer, my friend. Am I right? Yes sir, you are absolutely right. Now I am going to rub this part and we will discuss the next question. Now the next question is question number 2. What is given here? Time required to decompose SO2Cl2 to half of its initial amount is 60 minutes. If the decomposition is of first order, calculate the rate constant of the reaction. Now listen carefully what is given. The time required to decompose SOCl2 to half of its initial amount, my friend. Half, that is, my friend, this 60 minutes, it is T half. T half is equal to, my friend, 60 minutes. Am I right? Yes sir. If the decomposition is of first order, definitely calculate the rate constant. Now, if the decomposition is of first order, what is the relation between K and T half? Do you remember? Yes sir, K is equal to 0.693 upon T half. Yes, definitely. Now put this value 0.693 upon 60. Very simple. Again, the question is formula based. Write the formula, put the data, you will get the answer. Clear? Now I am going to rub this part, my friend, and we will discuss the next question. Wait for a moment. Now, question number 3. Read the question first of all carefully, what is given here. The activation energy for the reaction, this is the reaction, my friend, 2HI which gives you, my friend, H2 plus I2. Yes, and for this reaction the activation energy, that means to say EA is given here, that is 209.5 kilojoule per mole. Yes, at 581 Kelvin, the temperature here is given 581 Kelvin. Okay, calculate the fraction of molecules. Calculate the fraction of molecules of reactant having energy equal to or greater than activation energy. Again I am repeating, having energy equal to or greater than activation energy. Now what to do in this case? That is the fraction of molecules, listen carefully, the fraction of molecules having energy greater or equal to activation energy. X is equal to, my friend, N upon N, that is EA upon RT. This is the case, that is EA upon RT. Now moving here, check it out, what will happen? That is, what we get here, X is equal to EA upon RT. Now take log both sides. Okay, taking ln, log, that means to say that is log E, that is called ln, both side. Yes, what will happen in this case? That is ln x is equal to minus EA upon RT ln E. As we know, ln E is equal to 1. So this is equal to 1. Now put this value. Now what we get here, ln x, ln convert it into log, that is 2.303 log x is equal to minus EA upon RT, or log x is equal to minus EA upon 2.303 RT. This is the case, my friend. Now moving here, check it out, that is log x is equal to minus, what is the value of EA? EA has the value, my friend, in the given equation 209.5 kilojoule per mole divided by 2.303 into 8.314. What is the temperature here? That is, my friend, 581 Kelvin. Yes, now what you need to do, solve this. That is, x is equal to, we can write here, anti-log of this one, that is 209.5 divided by 2.303 into 8.314 multiplied by 581. After solving, you get the fraction of molecules. Clear to you? Having energy equal or greater than activation energy. Clear to you? These are the simple questions, and definitely, my friend, it will help you a lot. Now I am going to rub this part and we'll discuss the next question. Now the next question is question number 4. Read the question, what is given here, completely theory based question, my friend. Mention the factor that affect the rate of a chemical reaction. As we know, the rate of a chemical reaction depends on the following factor. Factors affecting the rate of a reaction. Now first of all, tell me what will happen. Yes sir, first of all, that is the nature of the reactant. Nature of the reactants. Generally, what does it mean? If there is a ionic, the ionic compound, the reaction is very fast. But if there is a molecular compound, the reaction is moderate, and generally in chemical kinetics we discuss about the moderate reaction. Second one is the concentration of the reactant. Higher the concentration, higher is the rate of the reactions. Clear? Now the third one is, my friend, that is temperature. With rise in temperature, the rate of reaction increases. Per 10-degree rise in temperature, the reaction becomes 2 or 3 times. Now the fourth one is surface area. Remember this, higher the surface area, higher is the rate of reaction. Clear, my friend? Nature of the reactant, concentration of the reactant, temperature, surface area, and presence of sunlight. In case of zero order reaction, as we know, the reaction proceed due to sunlight also. And the last one is pH of the medium, or you can say pH of the solution, or pH of the reaction. In similar terms we can write. These are the following factor we decide the rate of a chemical reaction, my friend. Am I right? Yes sir, you are absolutely right, and this will definitely help you a lot. Now I am going to rub this part and we'll discuss the next question. Now listen carefully. What is given here? Let's move to the next segment. Now this is a lengthy question. Listen here. In a pseudo first, what is pseudo first order reaction? The reaction which looks second order but its order is first, that is known as pseudo first order reaction. Here is given, in a pseudo first order hydrolysis of an ester in water, the following results were obtained. Okay, calculate the average rate of reaction between the time interval 30 to 60 seconds here and here. Clear? Now what is the first part of the question? Average rate of reaction is equal to C2 minus C1 upon T2 minus T1. This is the case. There is a reactant, so put here minus sign. What is C2, my friend? That is 0.17 minus what is C1? 0.31 upon T2. What is T2 here? That is 60 minus 30. This is the case. That is, we say that is the average rate of reaction is equal to minus 0.17 minus 0.13. That will be equal to, that is 0.14. Clear to you? Upon 30. That is minus minus plus, that is our average is equal to 0.14 divided by 30. This is the simple. As I told you earlier, rate of reaction never comes negative. Minus and minus, so there is a decrement in the concentration of the reactant as the time passes. Now moving here to discuss the second part of the question. Here is second part of calculate the pseudo first order rate constant for the hydrolysis of ester. Clear to you? Now rate constant, calculate the rate constant. Clear? So first of all, K dash is equal to, we know, 2.303 upon T log A naught upon A, my friend. Now put the value K dash equal to 2.303. Now which time I am going to look at? That is for 30, first 30 second, that is log A naught. A naught is given here 0.55. What is A, my friend? A is 0.31. This is, my friend, K dash for first. Now for 0 to 60, K double dash, we will put here 2.303 upon 60 log 0.55 upon 0.17. Clear? Now for 90 second, that is K triple dash, that is 2.303 upon 90 log, that is A naught 0.55 upon that is A 0.085. Put the data, you will get the answer. Clear? This is K dash, K double dash, 1 time 30, 60 and 90. Clear? Now friend, I am moving here. Check it out. Now what we get after solving, we get the rate constant. Now here is given, look at, here is given, calculate the pseudo first order reaction rate constant. Now 3 interval, so we will write here average rate constant, my friend. Average rate constant K is equal to K dash, K double dash plus K triple dash divided by 3. Put the value, you will get the exact answer of this reaction. Am I right? Yes sir, you are absolutely right, and this question definitely help you a lot, and this is one of the best question for competitive as well as for board examination, my friend. Now I am going to rub this part and we'll discuss the next question. Wait for a moment. Now the next one is question number 6. Look at question number 6. What is given here? A reaction is first order in A. A reaction is first order in A and second order in B. Write the differential rate equation. That is, we will write here R is equal to K, first order in A and the second order in B. This is the differential rate expression, my friend. Clear? So for this question, overall order of the reaction, overall order of reaction is equal to 1 plus 2 is equal to 3, my friend. Now the question arises, how is the rate affected on increasing the concentration of B 3 times? Okay. Now this is the first part. Second part is given, concentration of B changes to now 3B 3 times. Now what will happen? What is the new rate? Okay. Definitely R is equal to B is equal to 3B. Now as we know, R is equal to K A to the power 1, and now B we can put R dash is equal to 3B to the power 2. Am I right? Yes sir, you are absolutely right here. Now what will happen in this case? That is R dash is equal to K A to the power 1, 3, 3, 9, 9B square. Now again I am repeating here, R dash is equal to 9K A to the power 1 and B to the power 2. Now this one is equal to, my friend, R. So the new R, that is R dash, is equal to 9R, 9 times that the old R. This is the answer of question number 2. Now the question number 3, what is given here? How is the rate affected when the concentration of both A and B is double? What is given? When the concentration of both A and B is double. Okay. Now concentration of A here we can write 2A, and the concentration of B here, that is, my friend, 2B. Concentration of A and B is double. Now we know the new rate is equal to K 2A to the power 1 and 2B to the power 2. R double dash is equal to K into 2 square into A to the power 1 and B to the power 2. As we know, that is K A to the power 1 and B to the power 1 is equal to R. So we can write here R dash is equal to 8R. That is, the new rate becomes the 8 times of the old rate, my friend. Am I right? Yes sir, you are absolutely right. Now I am going to rub this part, my friend, and we'll discuss the next question. Wait for a moment. Now the question number 7 here, listen, Read the question carefully. What is given here, my friend? The half-life of a radioactive decay. The half-life of the radioactive decay is 5730 year. Okay, sir. That is T half is given here 5730 year. An archaeological artifact contained wood that had only 80% of C14 found in the living tree. Estimate the age of the sample. That is given here. A naught is equal to 100, 80%. So A is equal to, my friend, 80. Yes, and we have to find the T. Now, as we know, all the given here, that is the first order sample, in this case radioactivity, that is the first order. So what is the first order in this case? K is equal to 2.303 upon T log A naught, A naught upon A. Now we know A and A naught and A, but we do not know the T and K. So if you put the value of K, then you can easily get the value of T. Now we know K is equal to 0.693 upon T half. And what is T half given? K is equal to 0.693 upon 5730. This is the K. Now put this value here. What we get? That is 0.693, yes sir, divided by 5730 year is equal to 2.303 upon T log A naught. What is A naught here? 100. What is A? 80. After solving this expression, what we get here? We get the value of T, my friend. This is the case. Clear? Now I am going to rub this part, my friend, and we'll discuss the next segment of the question. Wait for a moment. The next question is question number 8. Now read the question carefully. That is the answer of this question, first part. What is given? A first order reaction takes 40 minutes for 30% decomposition. What is given? Take 40 minutes. That is A naught is given here, my friend, 100, and A is equal to, that is 30% decomposition. So A is equal to, my friend, 70, not 30, 30% decomposition. So remaining, that is A. Clear to you? Calculate T half. Okay. Now we need to find T half. We know T half is equal to 0.693 upon K, but we do not know here K. So how to get the value of K? Yes sir. K is equal to 2.303 upon T log A naught upon A. Yes, definitely log A naught upon A. Now put the value. K is equal to 2.303 upon T. What is T here, my friend? 40 minutes. Put here 40 minutes into log A naught here 100 upon 70. Yes sir. Now K is equal to, we know, 0.693 upon T half is equal to 2.303 upon 40 log 10 upon 7. Clear? Now you can easily get the value of T half. This is a simple one, my friend. Now the next one is 2. How will be the effect of the temperature on rate constant? As we know, per 10 degree rise in temperature, the value that is becomes 2 and 3 times, and it is symbolized by, my friend, Arrhenius equation. K is equal to A E minus EA upon RT. Taking log both side, L and K is equal to L and A minus EA upon RT. Clear to you? Now convert it into log. 2.303 log K is equal to 2.303 log A minus EA upon RT. Now what will happen? Come here, what we get here, log K is equal to 2.303 log A divided by 2.303 minus EA upon RT. Am I right? Yes sir, you are absolutely right. This will cancel this one. We can write here log K is equal to log A minus EA upon RT. This is the expression, my friend. That is the variation. Clear to you? The question looks tough, but the questions are not so much tough, my friend. If you have a command over the theory, then definitely you can solve such kind of questions. Clear to you? I am giving you few seconds to note it down. I think, friend, you have noted it down. Let's move to the next segment. Wait for a moment. Now, what is given here? Look at. The question here is the rate constant. The rate constant for the first order decomposition of H2O2 is given by, given here, look at, log K is equal to 14.34 minus 1.25 into 10 to the power 4 K upon T. This is the case. Calculate EA for this reaction. Now, what is the standard equation? As we know, log K is equal to log A minus EA upon RT. This is the case. Now, compare. This is log A, my friend, and this term is equivalent to EA upon RT. Am I right? Yes, sir. So, put here EA upon RT is equal to 1.25 into 10 to the power 4 K upon T. Am I right? Yes, sir. You are absolutely right. Now, this will cancel this one. Clear? Now, what to do next? That is, we will write here, that is the next segment, that is EA is equal to 1.25 into 10 to the power 4 into R, that is 8.314 K. Clear? That is, if I solve this data, then definitely you will get the answer, my friend. You will get the answer. That is the EA. Now the question arises here, and what temperature will its half-life period be? 256 minutes. Again I am repeating, at what temperature will its half-life period is 256 minutes. Now, I am going to rub this part. The second part of the question is given here. Half-life. As we know, that is half-life period be 256 minutes. Okay. K is equal to, we know, 0.693 upon T half. Yes, sir. Now, put here 0.693 upon T half. T half is 256. Clear? Now, put this value given here, log K is equal to 14.34 minus 1.25 into 10 to the power 4 K upon T. Now, log K, K value put here, log 0.693 upon 256. Am I right? Yes, sir. Is equal to 14.34 minus 1.25 into 10 to the power 4 K divided by T. Now, let's you can solve. We have I have put all the data. Now you have to get the value of t. So what I am telling my friend, the question is not so much tough, depending how much command you have on the theory. You can definitely solve each and every question of the of this chapter. Clear? Now I am going to wrap this part, my friend, and we'll discuss the next and final question. Now the next question is, listen carefully, read the question carefully. I am giving you few seconds. What is given here? The time required for 10% completion of a first order reaction at 298 Kelvin. Suppose the time required for 10% completion is T1 is equal to that required in 25%, that is T1 is equal to T2 is given. Yes sir, it is given. Now if the value of A is 4 into 10 to the power 10, calculate K at 318 Kelvin and EA. Then you have to calculate the value of K and EA. It's very simple. Now K, we have to find the value of K at 298 Kelvin. Now it is equal to 2.303 upon T1 log A naught upon A. 10% completion, so A naught is 100 and A is, my friend, 90, not 10. 10% completion, remaining amount is 90. Clear? Now T1 is equal to what to do? 2.303 upon K 298 into log 10 upon 9. This is the first phase of the question. We get the value of T1. Now again at K at what? 308 Kelvin. Okay, 308 is equal to 2.303 upon T2 log A naught, here is 100, 25 completion, that is the remaining amount is 75. Yes sir. Now what do we observe? T2 is equal to 2.303 upon K 308 log 3 and 4 log 4 by 3. Yes? Yes sir. Now moving here, according to the question, it is given here, that is T1 is equal to T2. Now put the value. What is T1? 2.303 upon K 298 log 10 upon 9. This is T1. Okay. What is T2, my friend? T2 is 2.303 upon K 308 log 4 by 3. Yes sir, log 4 by 3. Now what will happen? Look at, this will cancel this one, or we can write here, that is 1 upon K 298 into log 10 upon 9 is equal to 1 upon K 308 log 4 by 3 here. Clear? Now moving here, what we need to find, that is we can write here log 10 upon log 9, that is 3 square, upon K 298 is equal to log 2 to the power 2 minus log 3 upon K 308. Clear? Now what do we observe? That is K 308 upon K 298 is equal to log 2, that is 2 log 2 minus log 3 upon log 10 minus 3 log 3, sorry 2 log 3. Clear? Now if you put the value of log 2, log 3, log 10, then you can get the value of K308. It is equivalent to K2 and it is equivalent to, my friend, K1. Clear? Yes. Now we know, now the second part here, now we know log K2 upon K1 is equal to EA upon 2.303 R into T2 minus T1 upon T1 into T2. Clear? Now you put this value, that is K2 upon K1. Now put here log K2 upon K1 is equal to EA upon 2.303 R. R is 8.314. What is T2, my friend? 308. T1 298. What is T1? 308 and T2, that is, sorry, T1 298, T2 308. Now what will happen? We get the answer, my friend, EA. Question is so much lengthy, but again I am repeating, if you have a command over the theory, you can easily solve the question. Now again it is given here, calculate K at 318 Kelvin. Now the next one, again we know, now we know here, that is log K is equal to log A minus EA upon RT. Am I right? Now you have the value of EA from here. You have the value of EA from here and log K and log A. A is given here 4 into 10 to the power 10. 4 into 10 to the power 10 minus EA upon RT. Clear, my friend? Is it visible? Now put the value of R. R is 8.314 and T is given here. What temperature? 318. Now tell me, you can easily, EA you have from this equation, R you have, T you have, and log A you have. Now you can get the value of log K. These are the question. I think calculation part you can do. Clear to you? Now moving here, my friend. What does it mean, my friend? If you have a command over the theory, then step by step you can easily first write down the data, read the question carefully, what is given here and what is the relation. If you proceed in a systematic manner, then you can solve each and every question related to any problem of this chapter. So my friend, these are the few questions related to your board examination and practice question, and definitely it will help you a lot. In my next class I will discuss few more interesting things. Till then, bye bye. Thank you so much.